Hello students, welcome to MAGESH classes. In this presentation we are going to discuss about book back questions of the lesson Coordination Chemistry. Here I am discussing all the 20 questions present in the book. The solutions are explained with detailed manner. I hope that it is very useful to you. Keep on watching this channel. Let us move into the question part. The first question. The sum of primary valence and secondary valence of the metal M in the complex MEn twice OXCl is MEn twice OXCl என்ற அணுவு சேர்மத்தில் உள்ள உலக அணு மற்றும் அயனியின் முதன்மை மற்றும் இரண்டாம் நிலை இணைதிறன் மதிப்புகளின் கூடுதல். கொடுத்திருக்கக்கூடிய காம்ப்ளெக்ஸ் that is MEn twice OX complex Cl. இதில் EN அப்படிங்கிறது எத்திலீன் டைஅமீன். ஸ்ட்ரக்சர் CH2NH2 CH2NH2 இது எத்திலீன் டைஅமீன். தென் OX ஆக்சலேட் ligand COO minus. Both are bidentate ligands. Now calculate the primary valence. இந்த முதன்மை இணைதிறன் அப்படிங்கிற primary valence அப்படிங்கிறது ஆக்சிடேஷன் ஸ்டேட்டை குறிக்கும். State. It is also known as oxidation state. ஆக்சிடேஷன் ஸ்டேட் எப்படி கால்குலேட் பண்ணுறது? காம்ப்ளெக்ஸில் இருக்கக்கூடிய சார்ஜஸை அப்படி நம்ம என்ன பண்ணுறோம், ஆட் பண்ணி சம்மை வந்து ஈக்குவல் டு 0ன்னு எழுதிட வேண்டியதான். ஸோ எம் அப்படி வச்சுக்கலாம். EN எத்திலீன் டைஅமீன் அப்படிங்கிறது நியூட்ரல் லிகாண்ட், ஸோ 0. ஆக்சலேட் பாருங்க, அதோட சார்ஜ் வந்து -2, ஸோ அதோடைய வேல்யூ -2 போட்டுக்கலாம். ப்ளஸ் குளோரின் நமக்கு தெரியும், அதோட வேல்யூ வந்து -1, the sum is 0. ஸோ M is equal to +3. பிரைமரி வேலன்சி என்ன நமக்கு கிடைச்சாச்சுங்க? பிரைமரி வேலன்சி வந்து +3ன்னு கிடைச்சாச்சு. தென் இரண்டாம் நிலை இணைதிறன். What is secondary valency? It is the number of atoms connected to the central metal atom by coordination bond. இப்போ எத்திலீன் டைஅமீன் வந்து 2 இருக்கு. ஸோ இது வந்து பைடென்டேட் லிகாண்ட் அப்படிங்கிறது நம்ம தெரியும். ஸோ இது ஒரு கோஆர்டினேட் பண்ணிடுது. இதே மாதிரி 2 எத்திலீன் டைஅமீன் NH2 CH2 இப்படி எழுதிக்கலாம். ஓகேவா? ஒரு 2 லிகாண்ட். ஓகே. ஒரு ஆக்சிலேட்டோ இருக்கு, COO கன்வீனியன்ட்டாக இப்படி எழுதிடுறோம். COO இங்கே ஒரு COO மைனஸ், இது மைனஸ் இருக்கு, இது ஆக்சிலேட்டோ. அப்போ இது ஒரு பைடென்டேட் லிகாண்ட். இப்போ 3 பைடென்டேட்லாம் இருக்கும்போது நமக்கு வந்து டோட்டலாக 6 ஆட்டம்ஸ் வந்து மெட்டல் கூட ஜாயிண்ட் ஆயிருக்கு. 1 2 3 4 5 6. கோஆர்டினேஷன் நம்பர் அப்படிங்கிறது வந்து தி நம்பர் ஆஃப் ஆட்டம்ஸ் விச் லிங்க்ட் வித் த சென்ட்ரல் மெட்டல் அயன் பை coordination. So here 6, coordination number 6. அப்படின்னா செகண்டரி வேலன்ஸ் என்ன? 6. அப்போ ஆட் பண்ணால் 9. ஆன்சர் வந்து D. Clear? And excess of silver nitrate is added to 100 ml of 0.01 m solution of penta aqua chlorido chromium 3 chloride. The number of moles of AgCl precipitated would be 0.01 m திறனுடைய 100 ml பென்டா அக்வா குளோரிடோ குரோமியம் 3 குளோரைடு கரைசலுடன் அதிகளவு சில்வர் நைட்ரேட் கரைசலை சேர்க்கும் பொழுது வீழ்வடிவாகும் AgCl மோல்களின் எண்ணிக்கை. அந்த காம்பவுண்ட் பென்டா அக்வா குளோரிடோ குரோமியம் 3 குளோரைடு, பென்டா அக்வா குளோரோ குரோமியம் 3 குளோரைடு. ஸோ அதோட ஃபார்முலா Cr குரோமியம், பென்டா அக்வோ H2O வந்து 5 times பென்டா அக்வோ குளோரிடோ குரோமியம் 3. ஸோ இதோட சார்ஜ் வந்து 3. இதோட சார்ஜ் 3 இருந்துச்சுன்னா ஸோ இது 3, ஸோ இது நியூட்ரல், இப்போ Cl. இப்போ காம்பன்சேட் பண்ணுறதுக்காக வெளியில் பெரிய அடையக்கூடிய குளோரைடு வந்து 2 என்ன பண்ண போகணும். இதுதான் அதோட ஃபார்முலா, பென்டாக்கோ குளோரிடோ குரோமியம் 3 குளோரைடு. இது டிசோசியேட் ஆகிட்டுனா என்னென்ன அயான்ஸ் நமக்கு கிடைக்கும்? திஸ் குரோமியம் பென்டாக்கோ குளோரின் அப்படிங்கக்கூடிய ஒரு அயான்ஸும் இதோட சார்ஜ் வந்து 3. ஸோ ஒன்று போக இங்கே 2 + அண்ட் +2 Cl- சிம்பிள் அயான்ஸ் கிடைக்கும். ஸோ 1 mole of this பென்டா ஆக்வா குளோரிடோ குரோமியம் 3 chloride நமக்கு கொடுக்கக்கூடியது வந்து 2 moles of chloride ions. So you can write this 1000 ml and 1 molar, suppose the concentration 1 molar gives 2 moles of chloride ion. So when it is treated with the silver nitrate, it is converted into AgS. So 2 moles of chloride. Okay, so it may be precipitated as silver chloride by treating with the silver nitrate. Here the question is 0.01 m solution of 100 ml solution. So therefore this 100 ml, this 0.01 m gives how many moles? This is a question. So you can write this 1000 ml 1 molar gives 2 moles of HCl, therefore 100 ml 0.01. So you can cancel it like this. So it is 10, it will be 10. So denominator you have 10. This is equal to 2 into 10 to the power of minus 2. Here 10. Okay. 2 into 0.01, it is 2 into 1. This is equal to 2 into 10 to the power of minus 3. Okay. So you can write this 0.002 mole. Clear? Your answer is 0.02. The complex has a molecular formula MSO4Cl6H2O. The aqueous solution of it gives white precipitate with the barium chloride solution, and no precipitate is obtained when it is treated with the silver nitrate solution. If the secondary valence of the metal is 6, which one of the following correctly represents the complex? ஒரு அணுவுச் சேர்மம் MSO4Cl6H2 என்ற மூலக்கூறு வாய்ப்பாடுகளை பெற்றுள்ளது. இச்சேர்மத்தின் நீர் கரைசலானது பேரியம் குளோரைடு கரைசலுடன் வெண்மை நிற வீழ்வடிவை தருகிறது. மேலும் சில்வர் நைட்ரேட் கரைசலுடன் சேர்க்கும் பொழுது எவ்வித வீழ்வடிவும் தருவதில்லை. அணுவுச் சேர்மத்தில் உள்ள உலோகத்தின் இரண்டாம் நிலை இணைதிறன் 6 எனில் பின்வருவற்றில் அணுவுச் சேர்மத்தை சரியாக குறிப்பிடுவது எது? ப்ராப்ளத்தில் கொடுத்துருக்கக்கூடிய டேட்டா அதோட கரைசல் எடுத்து நம்ம என்ன பண்ணுறோம், நீர் கரைசல் எடுக்கும்போது அது கெமிக்கல் கூட ட்ரீட் பண்ணி பார்க்குறோம். தட் இஸ் வித் பேரியம் குளோரைட் சொல்யூஷன் அண்டு சில்வர் நைட்ரேட் சொல்யூஷன். ரெண்டு இதுவிடையும் தனித்தனியாக என்ன பண்ணுறோம், அதை ட்ரீட் பண்ணி பார்க்கணும். இப்படி ட்ரீட் பண்ணும்போது நமக்கு வந்து கிடைக்கக்கூடிய வீழ்வடிவை வச்சு ஒரு கன்க்ளூஷனுக்கு வரும். ரெண்டு கரைசல் எதெல்லாம் அப்படின்னா நம்ம ரெண்டு சொல்யூஷன் கெமிக்கல் ரியேஜென்ட் எதெல்லாம் சொன்னால், ஒன்று பேரியம் குளோரைடு கொடுத்துருக்கிறது வந்து பேரியம் குளோரைடு, இன்னொன்று வந்து சில்வர் நைட்ரேட் சொல்யூஷன். பேரியம் குளோரைடு கூட ஒயிட் precipitate கொடுக்கக்கூடியது எந்த ரேடிக்கல் அப்படிங்கிறது சல்ஃபேட். சில்வர் நைட்ரேட் கூட ஒயிட் precipitate கொடுக்கக்கூடியது எந்த ரேடிக்கல் அப்படின்னா Cl-. இதனால் பேரியம் குளோரைடு கூட ஒயிட் precipitate அது கொடுக்குது. ஸோ த பிரசன்ஸ் ஆஃப் சல்ஃபேட் அயன். இது வந்து சிம்பிள் அயனாக இருக்கும். சிம்பிள் அயனாக இருந்தால் தான் அயனைஸ் ஆகி வெளியில் வரும். சல்ஃபேட் இருக்கு. இப்போ சல்ஃபேட் வந்து என்ன பண்ணியிருக்கணும், வெளியில் இருக்கணும். இப்போ வெளியில் இருக்கக்கூடியது வந்து இதில் இருக்குது, சல்ஃபேட் இருக்குது, இந்த இதில் சல்ஃபேட் இருக்குது, இங்கே சல்ஃபேட் இருக்குது, சல்ஃபேட் இருக்குது. ஃபார்முலாவில் என்ன இருக்குது, MSO4Cl6H2. சல்ஃபேட் வந்து இப்போ கண்டிப்பாக காம்ப்ளெக்ஸுக்கு எங்கே இருக்குது, வெளியில் இருக்குது அப்படிங்கிற ஐடியா தெரியும். ஓகே. அடுத்தது குளோரைடு. சில்வர் நைட்ரேட் கூட குளோரைடு அயனில் வந்து precipitate ஃபார்ம் ஆகலை அப்படின்னா குளோரைடு அயன் இதுக்குள்ள இருக்குது, காம்ப்ளெக்ஸ்க்கு உள்ள இருக்குது, லிகாண்ட்ஸ்குள்ள இருக்குது. ஓகேவா? இதோட கோஆர்டினேஷன் நம்பர் என்ன கொடுத்துருக்கு, மெட்டலுக்கு 6ன்னு கொடுத்துருக்கு. அப்போ மெட்டலுக்கு கோஆர்டினேஷன் நம்பர் 6னா மீதி இருக்கக்கூடிய 5 என்னதான் இருக்க முடியும், வாட்டர். 5 வாட்டர் இருக்க முடியும். அப்போ ரிமைனிங் வாட்டர் எங்கே இருக்குது, இந்த ரிமைனிங் வாட்டர் வந்து H2O இங்கே இருக்கு. ஓகே. ஸோ அப்போ காம்ப்ளெக்ஸ் வந்து MH2O5Cl SO4H2O இல்லையா? அப்போ ஆப்ஷன் எங்கே இருக்கு நமக்கு, இதில் ஆப்ஷன் சி. ஓகேவா? கிளியர்? ஸோ பேரியம் குளோரைடுலேருந்து அதோட ஃபார்முலாவை கண்டுபிடிக்கும். அந்த precipitate வர்றது வந்து அதுமாதிரி சில்வர் நைட்ரேட்லேருந்து சிம்பிள் ரெடிக்கல் அண்டு காம்ப்ளெக்ஸ் ரெடிக்கல் நம்ம கண்டுபிடிச்சு அந்த மாதிரி ப்ராப்ளம்லாம் என்ன பண்ணிடலாம், ஈஸியாக சால்வ் பண்ணலாம். ஓகே. Oxidation state of iron and the charge on the ligand NO in FeH2O5NO FeH2O5NO அணுவுச் சேர்மத்தில் இரும்பின் ஆக்சிஜனேட் அயன் மற்றும் ஈனி NOவின் மீதான மின் சுமை ஆகியன முறையே கொடுத்துருக்க. FeH2O5NO SO4. The given complexes. What's the charge of this Fe and the charge of the Na? What charge? இப்போ இது அயனைஸ் ஆச்சுன்னா என்ன கிடைக்கும் நமக்கு? FeH2O5 NO. இது வந்து ஒரு காம்ப்ளெக்ஸ் அயன் அண்டு சல்ஃபேட் அயன். சல்ஃபேட் அயனுடைய சார்ஜ் நமக்கு தெரியும் 2-. அப்போ இது கண்டிப்பாக என்ன இருக்க முடியும்? 2+. ஸோ இந்த இன்ஃபர்மேஷனில் இருந்து தான் நம்ம என்ன பண்ணுறோம், இதுக்கு சார்ஜ் கண்டுபிடிக்க போகிறோம். அண்ட் இட் இஸ் திஸ் நைட்ரிக் ஆக்சைடு, தட் இஸ் NO நைட்ரசைல், அதோட சார்ஜ் வந்து இட் இஸ் பாசிட்டிவ் லிகாண்ட் அண்ட் +1. ஸோ இது என்ன பண்ணலாம், +1 சொல்லி எடுத்துக்கலாம். ஓகே, இது வந்து நியூட்ரல், வாட்டர் வந்து நியூட்ரல். இப்போ இதோட சார்ஜ் என்னதான் இருக்க முடியும்? Fe வந்து 1 இருக்க முடியும். அப்போ +1 இருந்தால் தான் டோட்டல் சார்ஜ் என்ன இருக்க முடியும்? அந்த காம்ப்ளெக்ஸ் 2 இருக்க முடியும். ஸோ சார்ஜஸ் +1 and +1 respectively. ஆன்சர் வந்து D. ஓகே. The fifth question. As per IUPAC guidelines, the name of the complex COEN twice ONOCl is. So it is the cationic complex. Cationic complex, the metal is cobalt. The name of the metal is as such, it is cobalt. So in the case of A, it is cobalt is given, and in the B, the cobaltate is given. So B is not the answer. And the C also the cobalt is given, D also cobalt given. So B may not be the answer. Okay, right. And ethylene diamine. Ethylene diamine is a bidentate ligand. Okay, it is a bidentate ligand, and it is ambidentate ligand. Bidentate ligands means the ligand has 2 coordination sites. So if bidentate ligand is there, prefix bis has to be added. Bis. In the case of ambidentate ligand, it has 2 mode of coordination. That is ONO may coordinate with the central metal atom by means of oxygen or by N. So it's a 2 mode of coordination. It is ambidentate ligand. If ambidentate ligand is present, the term kappa, that is K, is introduced. Okay. Then you have to find out the charge of the complex. See. So in case of cobalt plus ethylene diamine, the charge is 0. And nitrito, the charge is -1. And on chlorine -1, plus the simple chloride is only -1. So total is equal to 0. So cobalt, the charge is +3. Cobalt 3 is the oxidation state. The ligands are ethylene diamine and nitrito and this chloro. Okay. So in case of alphabetical order, chloro is first chloro, and then the ethylene diamine is present. So it is a bidentate ligand. You have to add the suffix bis. Ethane 1,2 diamine. Ethylene diamine parts over. Then ONO is the ambidentate ligand. Here it is connected to the metal ion by O. So it is KO, that is nitro KO, that is this connected to the central metal ion by means of oxygen atom KO. What is the central metal atom? That is cobalt. The oxygen state is 3. The simple ion is chloride. Okay, so this is the name. The IUPAC name should be in the continuous pattern, so there is no space between the cationic complex. So cationic complex, okay. So like this, the chloro, bis, ethane 1,2 diamine, nitro, KO, cobalt 3. Okay. In short, you have to remember this. Hence, your answer is cobalt 3 chloride. The IUPAC name of the complex K3AlC2O4-3s. The given complex is K3AlC2O4-3. It is the anionic complex. Correct? The anionic complex, the metal name is end with the suffix AT. So it is a metal aluminate. So the A may not be the answer. So it is given the aluminium. Okay. Then you can find out the charge of the aluminium. What is the charge of the aluminum? 3 potassium ion, that is 3 plus aluminum X, and oxalato. Oxalato is a bidentate ligand, so the charge is 2 minus 2 is equal to 0. So aluminum minus 3 is equal to 0. So Al is equal to plus 3. So aluminum charge is plus 3. So this is the option B may not be the answer. Okay. And this oxalato is a bidentate ligand, and so it has 3 bidentate ligands. So the suffix tris is included. In case of bis, it is 2, it is 3, and tetrakis, it is 4. So when bidentate ligands are present in 2 times, you have to add the bis, and bidentate ligands are present in 3 times, you have to add the tris. So here the tris is given, and in the option D, it's a tri is given. Now we can name it. The positive part of the complex is potassium, so it is potassium, and the complex is named from right to left. So there is 3. It is tris. The bidentate ligand oxalato is present, tris oxalato. Aluminum in the anionic complex, so the name is sent with the suffix ate, aluminate. The oxidation state of the metal is 3. So potassium tris oxalato aluminate 3 is the answer. Here it is given as potassium tris oxalato aluminate 3. So your option C is correct. The 7th one, a magnetic moment of 1.73 bm will be shown by one among the following: titanium tetrachloride, cobalt chloride complex, and copper NH3 plus, and the NaCN4 minus ions are given. So here we have to calculate the number of unpaired electron in the species. It is very simple. The titanium tetrachloride, the charge of the titanium is titanium 4 plus. Okay, the Cl minus is removed, you get the charge titanium 4 plus. The atomic number of titanium: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So it is atomic number 21, atomic number 20. Titanium atomic number 22. The electronic configuration of titanium is argon 4:3d2. In titanium 4 plus, it loses 4 electrons, so it is argon. So there is no unpaired electron. The Bohr magneton is equal to 0. Okay, so this is the first. See the next case, that is Cobalt Cl6 complex. The charge of the complex is 4 minus. What is the charge of the cobalt here? The cobalt plus minus 6. It is given by 6 chloride ion. This is equal to minus 4. Sum of the oxidation number is equal to the charge. So the cobalt has plus 2 charge. By solving this, plus 2. What is the oxidation number of atomic number of cobalt? It is 27. Cobalt electronic configuration is argon 4:3d7. Cobalt 2 plus is equal to argon 3d7. So what is the number of unpaired electron present in it? The chloride ion is a weak ligand. You know very well that the spectrochemistry concept. The chloride ion is a weak ligand. So the D7 configuration you can write. It will be T2G6 Eg. To all the 10 electrons can be written like this. Here only 7 electrons are present. So it may be, it is a weak ligand. So it is 2G, T2G 5, Eg 2. Okay, all the 7 electrons. So what is the number of unpaired electrons present in it? T2G level. In the case of D7 cell, you have to arrange the split the d orbital into 2 levels. One is the Eg level and another one is the T2G level. So it is a weak field. So it is electrons are filled like this: 4, 5, 6, 7. So it is T2G5Eg2. The number of unpaired electrons, here one number of electron, and this is one number of electron, 1, 2, 3. So N is equal to 3. So 4 magneton is equal to 3.93 Bm. B is not the answer. Okay. In C, the complex is given Brcl, Amin, copper 2+. The number of unpaired electron present in it. So copper, what is the electronic configuration? It is 29. So it is argon 3d10 4s1. So it is electronic configuration. Here copper is in the +2 charge. So copper +2 is argon 3d9. It is 2G6 Eg3. Number of unpaired electron is 1. How it is written? 2G6. It is the T2G level. It is the Eg level. So first electron, second electron, third electron, fourth electron, sixth electron, seventh one, eighth one, 5, 1, 2, 3, 4, 5, 6, 7, 8, and this is ninth electron. So you may write T2G6 and Eg3. So number of unpaired electron is 1. So Bohr magneton is 1.7 Bm. So your option is C. Okay. Next one, crystal field stabilization energy for high spin D5 octahedral complex is D5 octahedral complex, that is D5 system. The electronic configuration may be T2G5 Eg0 for D5 or T2G3 Eg2. It is a high spin. High spin means many number of electrons in the spin state. So this is not the electronic configuration. The electronic configuration is T2G3 Eg2. What is the configuration is 1, 2, 3 T2G and here. So first electron, second electron, third electron, fourth electron, fifth electron. So this is a stage. To calculate the CFSC, the number of electrons in the T2G level 3. So 3, the value of T2G is minus, it is lower in energy. So it is 3.3 into minus 0.4 plus 2 in the Eg level. So it is raised, energy is raised. So here it is 2 into 0.6 into delta octahedral. Okay. So this will be minus 1.2 plus 12 plus 1.2 minus 1.2 plus 1.2 into del 0. So this is equal to 0 into del 0 is equal to 0. The CFSC value is 0. Clear? Question number 9. In which of the following coordination entities the magnitude of delta octahedral will be maximum? The 4 options are given. So which of the following complexes having maximum crystal field stabilization energy? So this is the concept. So in all the cases the metals are same, only the ligands are different. Here the cyanide is a ligand, here the oxalator is ligand, aqua ligand and amine ligand. Ligands have some splitting ability of the d orbitals. So the d orbitals, the 5 orientations are splitted into 2 categories in octahedral field. Okay. So it is the same energy level. Here it is separated into 2 energy level. One is called T2G and another one is called Eg. So this is your CFSC, so splitting. This splitting pattern, the various ligand splitting pattern, they are arranged in the spectrochemical series. The ligands are arranged in spectrochemical series. It is based on the splitting ability of the ligands. The splitting ability of the ligands from spectrochemical series, the 4 ligands in the order is H2O, and here the oxalato, there's less energy, oxalato, then amine, the amine is in the greater ability than water, and finally Cn. So this is obtained from the spectrochemical series pattern. From this pattern we have known that the cyanide is a strong ligand, so it will split more, okay, and oxalate is a weak ligand, it split very less. So when you compare these 4 ligands, cyanide is a very strong ligand from spectrochemical series, and so the CFSC is greater for the complex A. Okay, so your answer is A. Yeah, so it is based on the splitting ability of the ligands. Okay, question number 10. Which of the following will give you a pair of enantiomorphs? See the enantiomorphs, enantiomers, it is nothing, it is the enantiomers. Enantiomers are the optical isomers of the compound. They have mirror image relationship, that is their images, object and images are non-superimposable. So the compound first one, that is CrNH3,4COCN6, it is a symmetric in structure, so it is optically inactive. So optically inactive, A is. In case of B, the complex is COEN twice Cl2Cl. It has 2 forms, the cis and trans form. The one is cis, CO, this octahedral complex. This format is cis format, and here the En is connected, so it is a cis. If this is placed in front of the mirror, you get the mirror image of the complex like this, CO. It is Cn, Cn. So it is a mirror images of the complex, En, like this. Okay, the cis form of this complex is object mirror image relationship, and so it possesses in the enantiomers. So these 2 forms are enantiomers. So it is very interesting that the transform of this complex, that is CO, it is the transform. See, these 2 chlorines are in opposite direction, En. When it is placed in the mirror, you get the same structure, so it is optically inactive. So cis form of this compound is optically active, so they act as a enantiomers B. So B is your answer. In case of C and D, it is a bimetallic complex, it has some symmetry, and here the 4 ligands, similar cis form is there. So here the trans form and cis form are not optically active, so your answer is B. Okay. Question number 11. Which type of isomerism exhibited by this diamine dichloroplatinum complexes? Okay. So the various options. In order to find out the type of isomerism, there's a trick to find out. For example, in case of coordination isomerism, isomerism is possible in the 5 bimetallic complexes. What are the examples for this? That is nickel, tetraamine nickel, tetracyanonickelate. So it is a example for bimetallic complex. 2 coordination complexes are there. In this type, you get a coordination isomerism. Okay. So the first one, the coordination isomerism, is not possible in these complexes. Okay. Then linkage isomerism. The linkage isomerism is possible only the complex having the ambidentate ligand. What is that ambidentate ligand? Ambidentate ligands having 2 modes of coordination. For example, this nitrate compound may coordinate with oxygen or with the nitrogen. So in this case, the linkage isomerism is possible. Here the ambidentate ligand is not present, so linkage isomerism is not possible. Then optical isomerism, the compound having object mirror image relationship. Okay. So in case of platinum complex, what is that? You write the NH3, Cl, Cl. It is a square planar complexes. There is no optical mirror image relationship, and so this optical isomerism is not possible. Only possible is geometrical isomerism. Geometrical isomerism, the 2 similar groups on the same side, that is, it is a cis compound, it is cis, and the diagonally opposite to each other, the two chlorine is opposite to each other, and similarly and the ammonia is opposite to each other. This compound is trans. So cis trans isomers are possible. So the compound exhibit geometrical isomerism. Okay. Next question: how many geometrical isomers are possible for this platinum, pyridine, amine, Brcl complexes? Okay. So it is a complex with the coordination number 4. Complex having coordination number 4. So compounds with coordination number 4 may be tetrahedral or the square planar. Tetrahedral complexes do not show geometrical isomerism. Only the square planar complex shows the geometrical isomerism. It is in the form of type M. The different ligands are present, A, B, C, D. That is, instead of metal, platinum, and for A, the pyridine complex ligand is present, and amine ligand, and Br ligand, and Cl ligand. So all the 4 ligands are different. In this case, the various probabilities arrangements are, you can write this: A, B, C, D. That is, the metal is arranged in the form. It is one pair, AB and another pair, ABCD. Then your next combination is AC and BD. That means this combination is A here, C here, and B, D. So now the BC are diagonal, here AB are diagonal. And one more combination, that is A, D, and B and C. Here the combination is MAD, B and C. So here the C and B are diagonal, and the A and D are diagonal. See here the B and D are diagonal, A and C are diagonal. So in this way you can write 3 different possible arrangements. So number of isomers are 3. Okay. So it is very simple. Ma3B, there is no geometrical isomers, and Ma2B2 only 2 geometrical isomers, and MABCD the number of isomers are 3. Okay. So in this way we can find out the isomers. The answer is A. So next question 13: which of the following pairs represent linkage isomerism? So we have already discussed in the question number 11. So different isomerism and a different trick to find out type of the isomerism. Here the question is, which one of the following pairs represent the linkage isomers? See here it is a bimetallic complex. The complex A is a bimetallic. A is complex, option A is given as bimetallic complex. In bimetallic complex, the type of isomerism is coordination isomerism. Okay. In option B, it is given the complex, the amine and NO3 SO4, and here the ONO is given. ONO, that is, the NO3 is ambidendate ligand. The complex having ambidendate ligand can coordinate with the 2 modes. Here it linked with the metal by means of nitrogen. In another case, it is linked with oxygen and a metal by means of oxygen. So it is a ambidendate ligand. So this ambidendate ligand is present, you get the linkage isomerism, because the 2 isomers differs in the linkage. Okay, students. Now the option C, there is NCS. NCS is isocyanate, and SCN, that is thiocyanate. Isothiocyanate and thiocyanates. Here the linkage is by means of nitrogen, the linkage is by means of sulfur. So it is also a ambidendate ligand. So ambidendate ligand is present, and the type of isomers exhibit linkage isomers. So the answer is both B and C. Option D. So in case the NO is ambidendate ligand, NCS, and the coordination is different. So these B and C exhibit linkage isomers. The answer is D. Which of the isomerism is possible for a complex CONH4 Br2 Cl? Geometrical and ionization, geometrical and optical. Optical and ionization, geometrical only. The given complex is CO NH3 4 Br2 Cl. The complex having the coordination number 6. So this is the cationic complex. In cationic complex, there is a ionization isomerism is possible. How it is possible? In cationic complex, suppose it ionized to give the complex ion and one simple ion Cl minus. The Cl is taken into complex and Br2 is taken out to complex. You get the structure CONH3 Br2 Br. So one Br is taken out, Br Cl. This complex gives Br minus upon ionization. So these are the ionization isomers of this compound. Okay. So this compound can exhibit ionization isomerism. So ionization isomerism is possible in this complex. So ionization is given in the option A and C and not given in the B and D. So B and D is not the answer. Okay. Then about the geometrical isomerism. So this is the octahedral complex. Here the two ligands, similar two ligands can be written in the cis position, and the remaining 4 ammonia ligands are written in the remaining 4 position. So this complex, this is the cis isomers. Under trans you can write CO two bromine is written in the opposite direction. So this is the trans isomers. So this compound exhibit geometrical isomerism also. So the answer is geometrical and ionization isomers. Next question. Which of the following complexes not expected to exhibit isomerism? Question number 15. The first one. The complex is Ni NH3 4 H2O twice 2 plus. For this complex you can write it's a tetrahedral complex. You can write geometrical isomerism for that. Here, 2 ligands are in the cis position. The 1-2 position is called cis. And you can write, transform this. What is trans? The 2 ligands H2 are in the opposite direction. That is 1-6 position. So for a complex A, you can write cis and trans. Similarly, the complex B given PTNH3 twice Cl2. So you can write cis and trans isomers for this. 2 Cl on the same direction and 2 Cl are in diagonally opposite direction. So you can write cis and trans isomers. And compound C. In compound C, CO NH3 5 times SO4 Cl. In this compound, suppose it ionizes, you get the Cl minus sign. So regarding structural isomerism, it ionizes to give the Cl minus ion. The same structure can be written as 5. The sulfate is taken out of coordination sphere. Now these two compounds are isomers, structural isomers, and this compound ionizes to give the sulfate ions. So the complex C also gives this. Complex C also gives ionization isomerism. Then what about D? The complex D, it is FeEn thrice. This complex, it is a bidentate ligand Fe. So it is linked like this. The Fe is the 3 bidentate ligands En is linked like this. You cannot write any structural isomers. By changing the structural, you cannot write any structural formers and also the geometrical ionization, etc. So the complex D does not show any type of isomerism. Your answer is D. A complex in which the oxidation number of the metal is 0. This K4 FeCN6. We have to calculate the oxidation number. K4 FeCN6. What is the oxidation number? The potassium oxidation number is 1. So 4 potassium plus Fe is in question, and cyanide oxidation number is -1. It is equal to the charge. So 6 into -1 is equal to 0. Sum of the oxidation number of the species in the compound is equal to 0. It is finding oxidation number rules. So 4 plus Fe minus 6 is equal to 0. Fe having +2 charge. Correct. By solving, F is equal to +2. Then D. In D, the complex is CN3 NH3. Okay. Now take this Fe and the cyanide, 3 into -1 plus amine. It is 0. Neutral ligand. This is equal to 0. Sum of the oxidation number is equal to 0. So Fe -3 is equal to 0. So Fe is in the +3 oxidation state. In the third case, FeCO5. Here Fe is in question and 5 into 0. Carbonyl ligand is the oxidation state 0. It is neutral ligand. This is equal to 0. So Fe, the oxidation state is in the 0 format. The question is asked, which of the following complex the metal oxidation state is 0? So answer is C. Question number 17. Formula of the tris ethane 1,2-diamine iron 2 phosphate is. See the complex FeCH3CH H2 This complex is not having, it is not a ethane 1,2-diamine. First of all, ethane 1,2-diamine, what is the formula? Ethylene diamine, simply say it is ethylene diamine, CH2, NH2. So this is the formula of the ethylene diamine, and it is neutral ligand. And phosphate PO4 3 minus, the valency or the charge is 3. Okay. So in this complex, this CH3, CH, NH3, NH2 twice, the ligand is not here, ethane 1,2-diamine. So complex A is not the correct option. The remaining 3 complex, the Fe, NH2, CH, NH2 thrice, and here the ligand is clear. So the answer B, C, D may be. Now regarding charge, the complex ion is in the +2 state. Suppose you calculate the oxidation state of the ion in the 3 cases. So next option is only the D. Now check out the D. See, oxidation number of Fe is X plus the ligand oxidation state 0, charge is 0, plus the phosphate ion is there, PO4 twice, it is -6 is equal to 0. Here you have to notice that this system is in the 3 times. So the ion is 3. So 3x is equal to -x is equal to 0, 3x is equal to 6, x equal to +2. Oxidation state of this complex is 2. So your answer is option D. Okay. So by this way you have to calculate the oxidation number and charge of the ligands, etc. You can predict the compound. Otherwise, you can write like this. It is the cationic complex. Cationic complex, this coordination sphere consists of tris ethane 1,2-diamine. Tris means 3 times in case of bidentate ligand. So CH2, NH2, NH2, CH2, NH2, 3 times. Here the metal. In the coordination sphere, the charge of the metal is 2 and the negative species is phosphate. In order to balance, the phosphate is 2 times and it is 3. Question number 18. Which of the following is paramagnetic in nature? The first one is the XII NH3 4 times and the charge of the complex is 2+. So the paramagnetic nature means if the complex having unpaired electron, it is para in nature because the moving electron creates a magnetic character. If all the electrons are paired, the complex is dia. Okay. Now apply this concept to the complex first one. So the complex 1, the zinc is in the +2 state. Okay, that is X and that is 0. The sum of the oxidation number is equal to 2. So the oxidation number of the zinc is 2. Zinc atomic number, that is Z, is equal to 30. Electronic configuration argon 3d10 4s2. In zinc 2+, what is electronic configuration in this complex? Argon 3d10. So all the orbitals in the d levels are completely filled. That is, there is no unpaired electron. So n is equal to 0. Hence the complex is diamagnetic. Clear? Then go to B. B, the complex is cobalt, hexamin cobalt 3+ ion. Okay. Cobalt, what is the atomic number? Z is equal to 27. So electronic configuration of the cobalt is argon 3d7 4s2. In this compound, what is the oxidation state of cobalt? So it is +3. Okay. So cobalt X amine is a neutral ligand 0. So total sum is equal to 3. So it will be 3. So cobalt 3+, what is the electronic configuration? Argon 3d6. Here the 3 electrons removed from both the cells. 2 electrons from s orbital and 1 electron from d orbitals. Okay. And one more thing, the amine is a strong ligand. It is, so you can see in the spectrochemical series, it is lost in the position. So it has a strong ligand. It has strong ability to split the d orbital. That means d orbital split into 2 levels. One is the T2G level, another one is the EG level. Strong ligand means this splitting is very high. Okay, so the electrons are not goes to the EG level, they gets paired into the T2G level. So all the 6 electrons, the first electron, that is 1, first electron in the first level, second level, third level. Here the energy is very large, and so they get paired. The electronic configuration is 2Tg6 and Eg0. Again, there is no unpaired electron in this case. So n is equal to 0. It is diamagnetic in nature. Okay. Then about C. In complex C, it is nickel H2O 6 2 plus. Here the nickel is in the +2 oxidation state. Nickel atomic number is 28. So electronic configuration is argon 3d8 4s2. Nickel +2, the electronic configuration is argon 3d8. 2 electron is removed from the s orbital by forming the nickel 2 plus. And what is the electronic configuration now? The electrons are filled in 1, 2, 3, 4, 5. It is a weak ligand. The splitting is small. 5, 6, 7, 8. So the electronic configuration T2G6 and Eg2. And it has 2 unpaired electrons. So n is equal to 2. So due to the presence of unpaired electrons, it is paramagnetic in character. So the C is para. So only the C is the para. So C is the answer. Then question number 19. FAC Meridional Isomer is shown by the FAC Meridional Isomer, that is facial isomer, Meridional Isomer. Okay. So what is Brcl and what is Meridional Isomers? In the octahedral complex of the type Cl, this is position, and the remaining 3 types of ligands are like this. That is the complex of the type Ma3 B3 type. Okay, so it is a typical example. See this example. The 3 chlorine ligands present in the corners of the one triangle. That is facial isomers, in which the 3 ligands present in the corners of one triangular face. So in 2-dimensional way, you can write like this. Okay, this isomer is called facial isomers. And what is meridional isomer? In meridional isomer, the ligands present in the opposing triangular face. So in the octahedral field, the ligands placed in the opposing triangular space, Cl, Cl, and one Cl is present here. Here ammonia, ammonia, ammonia. So in this complex, the 2 chlorine atoms are placed in 3 triangular face of octahedron. It is a 3 triangular face of the octahedron. Here, the 3 chlorine atoms are present in the opposing of the triangular face, and so it is called Meridional Isomer, simply MER. It is a FAC. So this type of isomerism is possible in the complex of the type Ma3 B3. See the complex here, En thrice Cl, Ma4 and B2 type. It is Ma3 B3 type. It is Ma5 B type. So our option is C. Question number 20, choose the correct statement. The square planar complexes are more stable than octahedral complexes. So regarding A, the tetrahedral square planar complex and the octahedral complex. Generally, the octahedral complexes are stabilized more in case of it is del 0 and del S. In case of octahedral complexes, the crystal field stabilization energy, and in case of square planar complex, the crystal field stabilization energy, it is stabilized more. So octahedral complex is more stable than square planar complexes. So statement A is wrong. Okay. The spin only magnetic moment of copper Cl4 to minus is 1.732 bm, 4 magneton, and it has a square planar structure. See the complex Cu, Cl4, 2 minus. Oxidation state of copper is Cu minus 4 is equal to minus 2. Cu is equal to plus 2. Oxidation state of copper is plus 2. So in plus 2 oxidation state, what is the electronic configuration? That is 3d10 copper, 3d9 4s1. The outer electronic configuration is like this, 3d10 4s1. In case of copper plus 2, what is the electronic configuration? It is 3d9. So from the electronic configuration, it is shown that it is number of unpaired electron is 1, and hence the 4 magneton will be 1.732 pm. So based on the electronic configuration, it is spin magnetic moment is 1.732 Vm, and it has the structure of, it has the sp2d hybridization, and the shape of the complex is square planar, and it is paramagnetic character. But in actual practice, because of some distortion, it has distorted structure is observed. So this statement is wrong. But in a theoretical aspect, it is sp2d hybridization and square planar complex and paramagnetic character. But experimentally, because of some distortion, that is called John Taylor distortion, it has some distorted structures. So this statement is wrong. Okay. Then about C. The CFSE of the Fe F6 4 minus and FeCN. It is a weak ligand. Fe fluorine is a weak ligand and it is a strong ligand. What about the CFSE? In Fe2 plus, in case of weak ligand, the electronic configuration of Fe2 plus, what I mean about 26. So electronic configuration is 3d6. It is 3d6 system. D orbital split into 2 different energy level. So it is a weak ligand. So electron goes to up level. And 6 electrons come here. So it is 2 3g4 Eg2. 1 electron is going to parity. CFSE is equal to 4 into 0.4. It is minus. Plus 2 into 0.6. Plus 1 pairing energy. 1 electron is paired here. So it will be minus 1.6 plus 1.2. This is equal to minus 0.4. In case of strong ligand, what happens? The T orbital split into like this. First electron, second electron, third electron, and fourth electron, fifth electron, sixth electron. So it is 2 2g6 Eg0 and 3 pairing is possible. So this is equal to 6 into minus 0.4 plus 0 plus 3 pairing energy is equal to minus 2.4 plus 3 pairing energy. In this case, only the 0.4p pairing, here minus 2.4 plus 3 pairing energy. So crystal field splitting energy of FeF6 and FeCN6, which one is greater? The FeCN6 is the greater. So C is also a wrong statement. In option D, the complexes are given. Vanadium complex, that is hexa aqua vanadium 3 plus 2 plus, and another one is the hexa aqua titanium 2 plus. The vanadium atomic number 23 and titanium atomic number 22. So here the vanadium is in the plus 2 oxidation state. So vanadium 2 plus, the electronic configuration is argon 3d. Okay. So in case of electronic configuration, the levels are T2G 3 electron and Eg 0. T2G 3. What is CFSE? The 3 electrons in the T2G level. CFSE is equal to 3 into minus 0.4 and no Eg and no pairing. So it is minus 1.2 delta octapetal. Okay. In case of titanium 2 plus, what is the electronic configuration? 22. So it is argon 3d2. So in the splitting of the d orbital, 2 electron present in the T2G level, 2 T2G2 and Eg 0. Now calculation of CFSE, it is 2 into minus 0.4 is equal to minus 0.8 del not 0. So which one has greater stabilization energy? The vanadium. So the given statement is correct. Okay. So correct statement is crystal field stabilization energy of vanadium H2O2 plus is higher than the crystal field stabilization of X-aqua titanium 2 plus ion. Okay. Okay, students. So we have completed all the 20 questions. I hope that it is very useful to you. If any queries on this, post your queries in the comment box. Thank you for watching.